Alright, welcome back to the series on algebra. And in this video we're going to have a look at identities, algebraic identities, and partial fractions. So in an identity, all coefficients of like powers are equal. So all coefficients of like powers are equal. And an identity must hold true for all values of x. So let's have a look at this in practice. Let's say we have the identity 2x plus 5 equals ax plus b. And this is true for all values of x. So we know this is an identity, then we can equate the coefficients. So we can say 2 is in front of the x and a is in front of the x, so we can say a is equal to 2. And we know that our constant terms are equal as well, so 5 is equal to b, or b is equal to 5. And if we had such a situation that maybe we had 2x plus 5 plus 2 is equal to ax plus b, then we would still know that a is equal to 2 because it's the coefficient in front of the x, and we could say b is equal to 5 plus 2 because it has a like power of x implied, x to the 0. So another way of writing that would be x to the 0. So 2x plus 5 plus 2 times x to the 0 is equal to ax plus b times x to the 0. And then we can equate the coefficients. That's just a kind of a subtler point, but we know that the constant terms are equal as well. So let's have a look at another slightly more complicated algebraic identity. This is a little bit more abstract, but if you get this, it'll help you with all algebraic identities. So ax to the 5 plus bx squared plus cx plus d is equal to px to the 5 plus qx squared plus rx plus s. So we see we have an x to the 5 here and an x to the 5 here. We can say a is equal to p. We have an x squared and an x squared, so we can say b is equal to q. And it's important that this holds for all x as well. So we also have a term in front of the x, or this term with c and an x, and then we have this term with an or and an x. So we can say c is equal to or, and our constant terms are then equal as well. So d is equal to s. And if we had an identity that doesn't even look particularly similar, like let's say we have ax cubed plus bx plus c equals px plus q, and this holds for all x, then we can say that we have an implied x cubed term here with a 0 in it. So we could write it out again if you wanted to. You could say ax to the 3 plus bx plus c equals 0 x to the 3, because we have no x to the 3 term here, so we have a 0 x to the 3 implied. plus bx plus q. Then we can equate the coefficients. We can say a is equal to 0, b is equal to p, and c is equal to q. So that too is an algebraic identity. Okay, so let's take a look at partial fractions. So if we are given the partial fraction 1 over x plus 2, the partial fraction problem 1 over x plus 2 times x plus 1, and we say that's equal to a over x plus 2 plus b over x plus 1, and this holds for all x, then we can actually solve this for a and b. So the first thing to do is to find a common denominator for these two. So we can say find common denominator for right hand side. So what we can do is you can put that over x plus 2 times x plus 1, and then we can say a times x plus 1 plus b times x plus 2 is equal to our left hand side, which is 1 over x times 2 times x times 1, x plus 1. And then we can simplify this fraction situation, and we can say 1 is equal to a x plus 1 plus b x plus 2. And then we can solve this with two methods. So I'll just write it out again. So the first method is to find values of a and b using this method. So since the equation is true for all values of x, we can pick two suitable values to evaluate a and b. So suitable values would be ones that make the a go to 0 here, or this term go to 0, and the other suitable value would make this term go to 0. So if we say let x equal minus 1, then this equation becomes 1 equals a minus 1 plus 1 plus b times minus 1 plus 2. And this will go to 0. And we'll be left with 1 equals 0 times a plus b times 2 minus 1 is 1. So b is equal to 1. And then next we let x equal to minus 2, because that will make this expression here go to go to 0. So if we say 1 is equal to a times minus 2 plus 1 plus b times minus 2 plus 2, this will go to 0, and we'll be left with 1 is equal to a times minus 1 plus 0b. And then we can say minus 1a equals 1, which implies a is equal to minus 1. And there's another method for solving these partial fractions as well. that has to do with equating coefficients and using simultaneous equations. So we'll have a quick look at that. So our original problem was this. So if we expand out these brackets, we say 1 equals ax plus a plus bx plus 2b. Then we group the terms with the same powers. So we'll say 1 is equal to ax plus bx plus a plus 2b. And then we can say 1 is equal to x times a plus b plus a plus 2b. And now we can equate the coefficients. So we see we have no x term on the left-hand side. So we can say we have 0x on the left-hand side. So the coefficient in front of the implied x is 0. So then we can say a plus b is equal to 0. So let's just write that out and actually just explain that better. So what we have is 0x implied on the left-hand side plus 1 is equal to x times a plus b plus a plus 2b. So we see that the coefficient here is the same as the coefficient here because it's an identity. So we can say 0 is equal to a plus b, which is how we got this expression here. So the next thing then is to equate the constant terms. So we can say 1 is equal to a plus 2b, which is the same as saying a plus 2b is equal to 1. And now we have two equations. We have this one and we have this one. So we have simultaneous equations. And hopefully we know how to solve those. So a plus b equals 0. It's our first equation. And a plus 2b equals 1, which is our second equation. We can subtract our first equation from our first equation. So we can write that out again. Minus a minus b equals 0. So what that is 1, or I, times minus 1. We just multiplied this equation here, this top one, by minus 1. And then we don't need to use that anymore. So we have a plus 2b equals 1, subtract minus a minus b equals 0. So these will cancel off, and we'll be left with 2b minus b equals 1, or b equals 1. And is that what we got above for b? So we got b equals 1 above. And now we can substitute that back in to equation, let's say 2. So a plus 2 times 1 equals 1. Then a is equal to 1 minus 2, which is equal to minus 1. And is that what we got above? So we got a is equal to minus 1. So then our expression to get full marks for the question would be 1 over x plus 2 x plus 1 equals minus 1 over x plus 2 plus 1 over x plus 1. Just double check that's correct. Yeah, so b is 1 and a is minus 1. And that is partial fractions. Thanks very much for watching, and hopefully we'll see you in the next video. Thank you.